it is reiterating that the issue really is with, especially if you're bringing WebGL onto the Windows platform, there's just a really low.
Something similar on top of it, on top of WebGL, or other techniques that are there that sits directly in your DOM. So it's declarative, has a C graph, and all the benefits you get from the stuff in your DOM data. So the next thing is, which is really probably the most interesting part, how to interact on your data. And what we allow is that you run HTML events on the 3D C graph. So you can use an add event listener or the Asian Netscape 2 style that you see here to register on click or on over or mouse over the X3D element to get this 2D pixel data to use the actually navigation, and then on click on the planets to fire up this Wikipedia page.
I just have a couple of minutes. I know you're here to see the technology, so I won't delay you before you get into the exciting things. I know you're distracted by the eye candy here. So, my name is Michelle Fox, and I'm the Chief Strategist for Workforce Development and Education at the U.S. Department of Energy. And you're probably sort of saying, what's the connection? And so I just wanted to jump in and provide a little bit of background on what inspired.
It's quite simple on the 3D side, and that's intentional. But it shows, hopefully, the level of interactivity and how 3D can be used to teach, and how it's a more exciting and immersive environment than just, say, a traditional picture or a PowerPoint slide or something. And so our library supports things like, you can see, hopefully you guys can see it good, but this window is pickable and can be manipulated up and down, and that's important to the training scenario. And then we have combined, HTML elements, and so with WebGL, that's an exciting opportunity to really see these all together in the same thing. And so we have this common technique is to create select objects that you don't want to show and see, but you need there for being able to give the person interactivity. So I'm gonna hide these here. So we can do that, and we've hid those. So now we see the door. So I think the first thing I'm gonna do here so I'm going to set this as a viewpoint. So over here I have a nice little tool, and I'll call, why don't we go ahead and create an animation. So I'll hide the grid line. So there's the book. So I can see it, and I can give it a name. So I'll give it a name here, and save that. So that's saved. So the last thing I'm going to do is pull out and make a viewpoint out here, and we'll call this one second. All right, so I've got a couple there, so I can move to first, and I can move to second. All right, so now this is where particle effects, and we've added shapes and more tools that the author can use. But I'll go to our messaging system, and right now it's probably more, well, it is more developer-centric, but we're starting with we had to pick a starting point. And so when the model's loaded, for example, I want the camera to position itself. I want the camera to position itself at that first viewpoint. So I select that in the effect. So when the model loads, the effect is moved to this viewpoint. And so I can pick that viewpoint here, first viewpoint, and we'll make that, say, 20 frames, and we'll save that as first movement. So I save that. Now I want to chain to that after the camera loads. I want to start that book. After the model loads, camera moves to the first position. I want to start the book animation. So a nice little thing here, we help the users when you go up here and do a preview. And hopefully I got everything right. So the camera moved the first viewpoint, the book comes off, and now we moved out. And that was without any code. So didn't have to know how to write a line of JavaScript at least to do that much.
So you can see here we have the muscle layer. You can go further down. See the skeleton, the organs, full interactive. Go down to the nervous system. The other cool thing you can do with this is you can also use it as a sort of a tool to look for parts of the human anatomy. So I can start typing here, say that I want to find a lung. Type this, it focuses on the lung. The thing is, if I want
So my name is Greg Tavares. I work at Google along with Vangelis and Ken. We made some WebGL demos this summer, and I thought I'd go over some of the techniques and we used to make them. So why do we make them? Well, I'll give you 4 reasons in the spirit of David Letterman. Number 4 reason, to promote WebGL, obviously. The number 3 reason is because it's fun. The number 2 reason, to make pretty pictures. And the number 1 reason is to diss Internet Explorer. Just kidding. No. Actually, it's really helped us find a ton of bugs, and we're still finding them. The more demos we have, the more things we find that we need to fix. Yeah. The first thing I did was all programmer art, which is this one. And so we still have the idea of the aquarium. We can put in some fish. And if we change the view till you're outside, you can see you're in some kind of room and there's this giant aquarium. The L button that somebody mentioned is you can give the sharks lasers. And they actually have to swim around to the other side before you'll be able to see them. But you can see one of the sharks shooting a laser out. There, it'll come on the screen in a moment. If you haven't played with this demo, a couple of things. You can set it to thousands of fish. This is it running across 8 machines. And like I said, because it's time-based, it doesn't actually have to keep the fish in sync. It only has to keep the camera and the settings in sync. That's a technique that just fell out because I didn't plan that originally. I just made my system time-based. But I know several games use this. Like if you've ever worked on, if you've ever played Burnout. Burnout 3 or 4 had a network play. And the players are all individually controlled, but the traffic around is all just a time-based simulation. And until you smack into one of them, they stay a time-based simulation. That way the system doesn't have to keep those cars in sync. And you can kind of tell this is inspired by some games on various platforms. The way it works is there's the meters come in, and when they hit, they birth 3 different particle effects, one for the smoke, one for the flames, and one for the little chunks of meteor. And there's also, I think, 20 spheres wrapped around the Earth. And when a meteor hits, I orient that sphere so its north pole, if you want to call it that, points to where it hit, and then one of the shaders scrolls the UV coordinates around the sphere to make the texture of the shock wave go around the sphere. And this is like a good example of if I put a lot of them up, there's no way I could draw this many little chunks if I had to draw that many in JavaScript. It's just not fast enough. So this is an example of a place where we really need to optimize by doing something like this. Is basically particle effects. Each particle effect in one draw call can draw 20, 30 of these little debris chunks.
And I do mean in. I mean it's part of the web. You can use it in the web.
Still an object host, and I'm not sure where these guys are going to show up. But I just tossed some more guys in there.
Untitled Labs people, as am I. So basically, they're talking about a product we're building. So we were, involved just to untangle all of this. The stuff that UN was talking about, this stuff that we put out as open source software. This is a product we're building to make 3D content sharing on the web, hopefully a little bit easier. So take it away, guys.
So now the interesting thing here is, right, we can actually go into this house. We can see what it looks like from the inside. We can pull it out. We can rotate it.
This is a simplified version. So he was doing, of course, audio processing and had these, FFTs of the sound stream as they were coming in. They were visualizing in 3D with WebGL. So this thing is taking like the most recent sound sample, but this is now synthetic. It's just producing sine waves, and loading it using text subimage 2D into subsequent rows of a texture, and then using that with the appropriate offset, and using vertex texture fetch to deform a mesh that's extending into the distance, right? So he said, well, if I just use one sine wave, it's fast, but if I use a sine wave with like this, cycle 1/8 the distance, then it gets slower. And as a matter of fact, he's right. It really did. And it's like, well, wait a minute. First of all, if we turn off anti-aliasing, it went faster. And this doesn't exhibit the problem as much here, I think, just because the screen resolution is lower. But if you want to come up later, you can see that the version that doesn't have anti-aliasing turned on ran a lot faster than the one that had anti-aliasing turned on. But the really crazy thing was that if you just changed how many sine waves are being displayed, okay, the performance actually changed, and changed a lot. There are some licensing restrictions on the Quake II model, so you can't run a server that's visible on the web. Okay, but you can see that the animation is now really silky smooth. If we get up close here, you can actually see that there's anti-aliasing going on, so that it looks better than the original Quake. Okay, and we can come in here and kill some bad guys.
YouTube.
Here we see the
explains the project.
simulation cube underlaid by processors, lots and lots of processors. And as we come in, we see there's particles in the cube. And particles are starting to interact. And then suddenly we see a doubling of the processors. And then a doubling again. And we're starting to see some interesting phenomena. So let's dive in and see if we can see something happening. And it looks like with our little observer camera, we're finding something interesting going on. A little bit of self-organization is happening here. Oh, a vesicle has formed, and it's got something inside it. Let's go on a few billion generations, and we have something a little more interesting going on in the vesicles. And a little bit more structure in this one, and a few billion generations later. And we've got a little bit of behavior going on. It's more of an entity. And we've got a really complex entity here. Let's push this along.
Thank you guys so much for coming out. It's been great. Thank you.